welcome to this episode under the buildingSMART Interoperability webinar series. In this session, we will show you best practices for how you can enhance data interoperability between Revit and Archicad BIM authoring tools. This knowledge will help you to meet your clients' model content requirements and facilitate your Corner X submissions. To start, we will have Ying Ying from BCA's Digitalisation Department explain what the model content requirements are about.
Okay. So I'm Ying Ying from Digitalization Department at BCA. So as Vanessa mentioned, the webinar will be focusing on the improving openBIM workflow using Revit and Archicad. So for my part, I will briefly explain the importance of interoperabilities for openBIM data exchange and some of the common issues encountered. The typical data workflow will start from data creation, data management, then move on to data exchange across different platforms and softwares, and eventually utilize data to generate data insights. At the data creation and management stage, the data is created by various originators. For example, Archicad will produce a BIM model, and ideally all the data should be stored and managed on a platform. And subsequently, the data will be exchanged across the project teams and regulators for specific purpose. For example, to meet clients' model content requirements and connect submission. This data sharing will involve data exchange across different software. With the structured data collected, then it can be used to generate actionable insights. The model content requirement is part of client's contractual requirement to outline information durable for BIM files across various project stages. MCR also integrates IFC datasets to support Corner-X submission. Getting BIM model with correct information at a specific project stage is essential to foster project collaboration. MCR allows data to be built up by stages. So for example, the illustration on the upper right-hand corner here, you can see that the material for ceiling and other information is required at design stage, while the manufacturing information and other information, and it will be only required during construction stage. In addition, MCR incorporates IFC requirement on top of the data for project delivery. So for example, fire rating is the data required for regulatory submission, and the installation date is the data required for project delivery. This incorporation allows the same BIM model to be used for both Corner-X submission and project delivery. We will have another webinar on 26 September on MCR and interoperability tools. We will elaborate on this topic further during the webinars. So please register for the webinar to learn more about MCR and relevant interoperability tools. This diagram here demonstrates how the data is exchanged for regulatory submission purpose. BIM models and data are generated as schematic design and detailed design sketch by architects and engineers for Corner-X submission. BIM model will be coordinated and submitted in openBIM format for automated checking and submission review via collaboration platform. After getting the authority approval, the BIM model will be exchanged back at the tender stage to make sure the buildings are constructed according to the approved design. Given that IFC format is mandatory for data exchange for Corner-X submission, ensuring interoperability for openBIM workflow is essential for project success. As the data exchange occurs between various software for different use cases, we will need to work out interoperability, especially between the BIM software using openBIM formats. BIM interoperability is the ability to exchange necessary data of BIM models from one software to another. If the data could not be exchanged effectively, additional efforts will be required to generate data, which is counterproductive. To address this issue, we aim to enhance interoperability for achieving efficient data exchange. There are two typical workflows for BIM data exchange. One is to use native BIM format or connector to exchange data between solutions from the same brand or two specific software from different brands. The other one is to use openBIM format. So for example, IFC files to exchange data between softwares from different brands. BIM interoperability issues may happen when use openBIM formats. In order to reduce this kind of issue, the user will need to have necessary knowledge to work around, and we will share some of the examples of this kind of issues. For software which are not IFC compliant, we will have to leave it to individual solution provider to get an IFC certification. So we will not elaborate on the issue related to this case. These are some examples of the interoperability issues encountered when using IFC to exchange data between Revit and Archicad. For scenario 1, the curtain wall panel from exported IFC file could not be captured in Revit for collision takeoff because it was not properly classified in Archicad. For scenario 2, the wall exported to IFC become hollow instead of solid. These scenarios are caused by lack of know-how and can be resolved by proper modeling procedure. So the approach to address this issue will be explained by Sagar and Vimal in a subsequent presentation on the best practice. So now I will hand over to Vanessa to introduce the buildingSMART Singapore standard to support data exchange. Thank you.
Thanks, Ying Ying. Hi, I'm Vanessa. I am a director at AcePLP and also the secretary of buildingSMART Singapore. And today I'm making a presentation on the openBIM workflow about different kinds of IFC versions and model view definitions. All right. AcePLP is a data specialist for the built environment. We create, organize, and manage information for our clients. And in this case, I'm presenting as buildingSMART Singapore, which is the Singapore chapter of buildingSMART International. And our mission as buildingSMART is to bring together the global industry to develop and implement open digital standards and services that can support us to automate our processes and make decisions across the built environment lifecycle to improve productivity, sustainability, and profitability. So let's have a look at what's the big deal and why interoperability matters to you and what you need to know about it. First thing, open standards help you to open the file. An open definition of a data standard allows everyone to interpret the data, being able to always having the guarantee to access your data. And also, it's also important for collaboration and consensus because everyone in a project together with you would have the ability to use the data and define how it should be exchanged. That gives you the power to choose the appropriate tool for the discipline that you are working in and the company that you are working at. And that gives you the power to control your own workflows now and also forever in the future. So let's have a look at some facts about IFC. IFC stands for Industry Foundation Classes. I was going to say International Friendship Club because, you know, within the buildingSMART community, we also forge friendships. So I invite you to join us there. But IFC officially stands for Industry Foundation Classes. It's the foundation of openBIM, and it's the main standard developed by buildingSMART. It's an open source file format that enables interoperability between various BIM software applications. IFC is the basis for exchanging data between different kinds of software applications through openBIM workflows for building, design, construction, procurement, maintenance, so on and so forth, across project teams and across software applications. It's a semantic schema built on classes, which defines all objects or entities which exist in this standard. This definition does not only include the name, but also similar to, categories in Revit and Archicad, it's also the relationships to other classes, standard properties, and also the way that the geometry is described. A semantic schema defines the way that the building-related data is described and inherited. This also means that you can open an IFC file in a simple text editor and view its contents in a text format. It's also versioned, like you can see over here. So you can see, so you can track its history because IFC definitions are regularly updated and developed by buildingSMART, and you can use the version that best suit your needs. So for example, the IFC format allows better representation of complex geometries. And IFC SG is based on the IFC 4 reference view with some additional regulatory data requirements. A lot of data exchanges for Revit users still occur in IFC 2x3 because it's a stable format certified in Revit and recommended for production by the Autodesk team. Anyone can contribute to it by being a part of the buildingSMART community. So you can see that it invites you to suggest improvements. It's also a transparent process where you can follow on GitHub, and everything is openly available at the buildingSMART website. So how big is the IFC? The IFC schema is extensive and very detailed because it's meant to cover a wide range of information relating to building and infrastructure projects. It includes hundreds of classes, attributes, and relationships. Its purpose is to enable interoperability between different software applications in the construction industry. And so it needs to be comprehensive, large enough to cover a wide range of use cases across different domains, right? Some of us here are architects, engineers, construction managers, and facilities management, and it needs to serve us all. It's large in terms of schema complexity, reflecting its role as a comprehensive data model for everyone in the construction industry. For that reason, there are many IFC classes than inside each of the software applications for two reasons. Number one, that IFC classes are often more granular, and there are many classes that don't describe physical elements or don't have representation in a particular authoring tool. For this reason, we have Sagar and Vimal today to present on how you can organize your BIM models to achieve the best results in your IFC export. Now, in an ideal scenario, you coordinate with an IFC file as a reference within your design editing tool. So, for example, an architect that creates the BIM model in a native design tool, shares it with an MEP design team after exporting it to IFC and use that for coordination. What the MEP team needs to do is not to open the architect's IFC file to edit it. Rather, they are using it as a reference file into their own design tool so that they can create and amend their own MEP BIM model accordingly. But what the MEP engineer can also do, as illustrated in step 4, is that the MEP engineer can also use the IFC model in a simulation tool for analysis purposes. And if you find an error in the IFC file that was shared together with you, and you need to make some changes in the architect's IFC file in this example, what you should do then is to request a change from the discipline author, which in this case is the architect. So that's the ideal IFC collaboration workflow. The other important part of the IFC standard is this thing called model view definition. As you can imagine, the IFC schema is like a dictionary. It describes every possible object within the built environment. And the MVD is a subset of the IFC schema. Official MVDs are developed by buildingSMART, whereas there can be custom MVDs that can be developed by others like software vendors. So we always need a model view definition that defines this subset of the schema for a specific use case. In this image, for example, one MVD is a coordination view MVD, and that provides you with the information that you need for coordination purposes. Another example is a reference view MVD, and the purpose of that MVD is to provide you with an IFC file or reference view purpose. The purpose of that MVD is to ensure that specific data or geometry is transferred between software applications in a standard manner. MVD determines how you can use the IFC file because it enables a specific data exchange scenario. So for example, in this case, you can see an IFC4 reference view in the second last option of the red box. That is for the standard delivery of a reference model in IFC4, and you can use it just as a reference. It may be quite detailed, but it's not meant for editing purposes. I've got another example, the IFC coordination view, for example. It's optimized for a coordinated exchange between BIM models, between the disciplines in the building industry. And the IFC 2x2 is only used in isolated cases. In this case, for MVDs in software that does not support IFC 2x3, then you have to go and perhaps try out IFC 2x2. To identify which MVD is used in an existing IFC file, you simply open the file in a text editor, any text editor of your choice, and the header would contain all information about the MVD, the exact IFC exporter version, and the software that it has been exported from. buildingSMART certifies the MVDs, and you can find this list on the buildingSMART website. There are 3 base MVDs that are the base levels of software implementation. There is the coordination view for 2x3, the reference view for IFC 4 and 4.3, as well as the alignment view for IFC 4.3. Exchange requirements can be defined on top of these base MVDs. It increases the interoperability between different domains. And on top of these MVDs, there are also use cases defined for architectural, structural, MEP, infrastructure use of the MVDs. Software tools can get certified against these use cases, and everyone could create their own MVDs and approach software vendors to implement it. Now, there is some flexibility there with the MVDs, but the problem with that is also that it results in a situation that several MVDs may not be interoperable with each other. So, for example, a software that supports reference view cannot automatically support the precast MVD. So then, in this case, how can we define exchange requirements, like the one that Ying Ying talked about? Now, the buildingSMART recommendation is that exchange requirements should be specific and checkable, because if it's not checkable, it's also not enforceable. So our recommendation is to make use of the information delivery specifications that outlines the specific information requirements for a project. It details what information needs to be delivered by whom, in what format, and at what stage of the project. And it also ensures that all parties involved in the construction project understand the data that they need to provide, facilitating a consistent and accurate information exchange. So at the start of a project, the IDS is developed based on the employer's information requirements, like the MCR, setting out clear expectations for the information that needs to be delivered throughout the project. In the design development phase, as the BIM modeler, we can use the IDS to inform us on what kind of information needs to be embedded within the BIM models. So as we are creating it with the end in mind. This ensures that the models that are created are developed with the correct level of detail and contains all the necessary information. As the project progresses, for example, in the construction stage, the IDS can also be used to ensure that the model and information shared by different parties within the project, like contractors and subcontractors, are consistent with the project's requirements. And at the end of the construction phase, the IDS can also guide the handover process by detailing the information that should be provided back to the client. So it serves as the backbone for information management within the openBIM workflow, ensuring that everyone has a clear understanding of what their information delivery obligations are. And then there are other buildingSMART tools, such as the buildingSMART Data Dictionary, written here as the BSDD, and the BIM Collaboration Format, the BCF. They play vital roles in supporting the information delivery specification and the overall BIM workflow, openBIM workflow. The BSDD is a comprehensive database that standardizes terminology and definitions across the BIM industry, ensuring that everyone has a shared understanding of the terms used in the IDS and throughout the BIM process. Whereas the BCF, or the BIM Collaboration Format, is a standard format that allows different stakeholders to communicate and manage the issues directly within the BIM model without making any changes to the BIM model itself. So what the BSDD and the BCF does is it complements the IDS by providing necessary tools for standardizing and managing information. The IDS specifies what information needs to be delivered, and the BSDD ensures that this information is standardized, while the BCF helps you to manage the communication and resolution of issues related to this information. Both the BSDD and the BCF are based on buildingSMART's open standards, which align with the principles of openBIM. This ensures that the entire process remains open and enables seamless collaboration across different software platforms and tools. By using these tools, you can better control the quality of the information delivered, making sure that it is accurate, consistent, and aligned with your project requirements. This supports the overall goal of the IDS to deliver the right information at the right time. And together, all of these tools ensure that the information delivery process is efficient and consistent, and it achieves the broader openBIM objectives. All right, I hope that helped you to understand what the complete openBIM workflow is. If you're interested to learn more, buildingSMART Singapore is soon rolling out an international IFC education program called the Professional Certification Program. So this program supports the openBIM process by ensuring that professionals working in the BIM environment have the knowledge and skills to implement and manage openBIM principles using tools that was covered in this, briefly talked about in this presentation, like the IDS, the BSDD, and the BCF. So keep a lookout for it and follow buildingSMART Singapore's socials. You can follow us on LinkedIn to find out when this program is launched. I will now hand over the time to my fellow presenter, Sagar Thorat from Autodesk, and he will talk to you about best practices for working within the Revit environment. Sagar, over to you.
All right, thank you, Vanessa, for a great presentation. And good afternoon to everybody. So my screen is visible to you, right? You can see the... Okay, so best practices in IFC interoperability. Now, this is probably the first of its series that we would have around this topic. There is a lot of good work happening around IFC interoperability in the Autodesk world, as well as the interoperability with other softwares like Archicad or Tekla, for example. So we definitely want to engage with multiple customers and give them insights on how they can improve their workflows as they prepare for the upcoming CoronaTech submissions as well. So I'm an architect and as well as an engineer and an ISO certified practitioner. So we'll go through exporting of IFC files in Revit, linking of IFC files, and opening of IFC files. So these are the three ways data can be exchanged inside of Revit when you talk about IFC data. So first, exporting IFC files in Revit. Most of us should be aware of this. Otherwise, it's more of a repeat for those. So first things first, you are normally exporting. Let's say, for example, you have prepared your Revit models and added IFCSG properties, model definitions, and now you're ready to export this out. So when you do export, it's important to know the three key points here, right? So I'm just gonna use a highlighter like here. So first thing, standard mapping should be working for most of the use cases, right? Unless you have done your own IFCSG mapping. Otherwise, you can use the IFCSG mapping file. You can focus on classes for Revit categories, support for Revit subcategories. IFC types is limited on the global level, right? So remember that the focus of the classes should be from the Revit categories as well as their subcategories. Third, you can reset the hard-coded settings by deleting the standard file and then selecting the standard. The standard file is located here in this C programs Autodesk RVT 2021. You can always delete that text file and you can import a standard file or load a file from this particular menu. Okay, it's just an XML file which can be used, or a notepad file. Okay, so class mapping at an element level, right? At an element level, Revit slab can be classified as IFC slab and IFC covering. Yeah. Now, if you look at IFC slab, the subtype will be a floor, a roof, landing, base slab, for example, or IFC covering can be ceilings, floorings, roofing, and molding and insulation. So how do you classify this, right? Say, for example, you have, if you want to find a subtype and you want to sort of, let's say, look at this particular wall. And here you see the export to IFC as. In the Revit 2023 versions and 2024, you can actually find it in the 3 dots over here, just at the IFC parameter group. And inside here, you should be able to find those, right? Say, for example, we are here at the wall. So you find IFC wall. Then you can see the predefined type can be found as parapets, partitioning, plumbing, shear, solid, and so on. These are all the predefined types. Okay. Another option is also to use the Autodesk interoperability tools to do this. Yeah. All right. So if you look at the class mapping at an element level, that is what exactly I just showed you. If you look at the wall, any kind of the IFC export as, again, can be mapped with your parent class as well as the subtype, okay, using the IFC export as function, or sorry, export to IFC as function. In the previous versions of Revit, we had the export to IFC as functions, but now to globally create a simple nomenclature for all languages, like non-English speaking customers as well, we have changed that classification to export to IFC as, right? Instead of, so you can see that in the past, again, it was IFC export as. Now it has changed to export to IFC as. Take a note of this. And there is a direct instance access to a drop down where you can find the IFC classes, right? The IFC by product in the schema, and the IFC predefined types here. Okay. So that's a change that you need to take note of. Okay. Now, finding the IFC classes in the documentation. So buildingSMART provides all sorts of documentation. In this case, if you want to look at the IFC 4.1 documentation, you can see all the schema here. Like, for example, if you look at covering, under covering, you'll be finding, let's say, for example, here, we have the floor type and so on, right? So there's ceiling, there is flooring, cladding, roofing. So IFC covering and the type enumeration is under this type. Okay, so you can always find these definitions on the buildingSMART website. So Revit simply follows the schema, okay, and the predefined types. We don't create anything new because Revit is fully certified for architectural data exchange, structural data exchange, and MEP data exchange for IFC 4.1. Okay, now as a word of caution, you have to be careful with overrides and not to overrides the current classes. You can export a Revit wall as IFC railing, right? Sometimes they do that, but should you do that, please ask a question to yourself. Yeah, that our wall can just be a wall. Keep in mind, every category in Revit has its different properties. So the IFC exporter can't create properties, but only map existing ones. And use intended Revit categories when possible. Now let's look at the export settings. Export setting, most of you would know that. You can see these are the IFC4 reference view structure, and IFC4 design transfer view, as well as building services. These are the predefined setups that you can use for exporting. These are export setups, okay? These are not mapping setups. Mapping would still have to be done through the mapping table. Okay, and you can also edit the in-session setup and create your own JSON file setup for your subsettings. Then you can either use Revit property sets, but in normal conditions, you would use the IFC common property sets to be exported. Okay. Now, properties in IFC, there are custom user defined properties, which are defined in the IFC schema and should always be your first choice to use the common properties that are defined. IFC common properties are defined by the user, but can be defined when you need them. You can always have the custom properties. In this case, as you know, IFCSG is a custom subset of the IFC classes itself. So that is where IFCSG can be a country-specific IFC that is out of the IFC class, but still follows the same system, classification system. Okay, so what are common property sets? Again, for each one of the classes, you will have the common property sets. So these are the common property sets. You can find them on the buildingSMART's website. Okay, now exporting is straightforward. Now we come to linking of IFC files. Linking of IFC files should also be quite straightforward. You can link them directly or you can link them through the managed links. There are two ways to link IFC files. Now, linking of IFC files in Revit, please take note of this, that instead of opening the IFC, this option allows updates at a later date, right? Like if the model changes or the IFC changes, you can refresh this model. This process is similar to the linking of other Revit or CAD files with Revit. Okay, it just links, doesn't give you the edit rights, so doesn't create a Revit file, but it allows you to link the information and extract properties out of the information, as well as value, as well as quantities can be extracted from those. So you can actually create a IFC schedule from IFC properties and also do a quantity takeoff inside Revit using the IFC models itself. And using Dynamo, you can also do much more. You can extract the full database, or maybe you can even compare between two IFC models. Fourth, the IFC file is automatically updated at the start of the project and can be manually updated at any time. Okay, like reloading the links. Yeah, everybody is aware of reload, right? Revit automatically creates a Revit file in the same folder which contains the IFC file. Now remember that you're not supposed to open this Revit file. This is just by default created such that it captures the element IDs of Revit and as well as reports them back into Revit as well. Remember that element ID IFC files exported from Revit, and when they are imported inside Revit, they do carry the element ID and it is renamed as IFC tag. Okay. Now, linking of IFC files in Revit, you should not move, change, or open this file. The ifc.revit should never be moved or changed. Okay. Remember, do not do that. Otherwise, you will lose some of the data. Linking IFC files is the preferred option for coordination purposes and gives the best results because it does not generate a native Revit element. It does not generate a native Revit element. Remember that. There are no detailed settings for linking of IFC files as the system automatically generates the best result. The export settings play a far greater role in the quality of the linked file. Therefore, if the data in the imported IFC file is not correct, 90% of the time, the issues are in the export mapping, okay, and not in the importing itself. But of course, importing settings also matter. So when linking an IFC model, a shared parameter file is also created, and this can be used to create filters that allow the selection, graphic overwriting, or hiding of the components. Okay. Now, finally, opening of IFC files in Revit. Now, in some cases, it is necessary to open the IFC file in Revit to continue editing it. Yeah. This workflow is not fully recommended. Now, this is the workflow that the projects that use both Archicad and Revit are using, because Archicad architecture models would have to be opened into the construction models to either be recreated or to be edited, right? Or to combine them with the structure and the MEP models in Revit. So this kind of data exchange can be done by opening the IFC file and making it editable, that you can link together with the Revit model as well, right? But remember this, that it is not recommended. However, some projects do that and the risk is understood by the contractor or the consultants. When importing, Revit transforms each element contained in the IFC file into a native Revit object. Remember, for this reason, importing large models can also be quite time consuming. Okay, so this is the import mapping table. Just like the export mapping table, in the open dialog box, you also have the import mapping table. Okay. And it's important to map it correctly. Now remember that while importing, you will have these two options. One is auto join elements, another is correct lines that are slightly off the axis. So this connects the elements automatically. Same approach as that is applied in the Revit modeling. This can lead to undesirable results for complex structures or export long times. I normally prefer to keep it unchecked. Okay, remember, this is to be kept unchecked while importing. Second, correct lines that are slightly off axis. So this can be left checked as a link CAD import function. This seeks to correct the elements that deviate slightly from the main axis. It can lead to problems with elements which are meant to be off axis, right? Now, if that is the case, then you can also keep this unticked, okay? But this definitely is an untick. Now, let's look at differences. Linking means you're intending to use for reference and coordination. This gives the best result and maintains the development focus. In no editing of IFC file is possible. Opening of IFC file, you can import the content of the IFC file in Revit, can lead to data loss and errors. Currently recommended is IFC 2x3, but IFC 4 can also be. However, the import still works with IFC 2x3. Now, you can always use a minimal template, no preloaded families. Secondly, standard mapping should be working, but many a times you can do some editing changes based upon own unique requirements, whether you're bringing the model from Archicad or Techline to Revit. Based on that, you can have a separate template created and saved as, right? Like a text file, save as a text file. Now, this is one example of a model to be bought from Revit. Now, by default, the ceiling, the ceiling in Revit is import mapped as a generic model when it comes from other softwares, right? And this generic model, if not changed to ceiling, you will see the ceiling getting imported as a generic model. However, if you change the generic model to a ceiling over here, right, then you will get the ceiling as a ceiling in Revit, okay? And it makes it editable. Remember, the mapping Revit category needs to be changed. You won't be able to change the class name, but the Revit category needs to be changed here. You can edit this point. And last example is the column example. In this case, you will see that the column from Archicad was exported and it went as a building IFC proxy element, right? Now, that is a generic model. IFC proxy element is a generic model. Hence, you will see that a column, when opened in Revit, is shown as a generic model. So anything that you open in Revit as an IFC, you will see that it follows the Revit category that was mapped in the import mapping file. Therefore, the import mapping file is of significant importance, and you can create your own templates and save them. Okay. Now, lastly, the recommended steps to make sure that that your files get interoperated correctly. First, you can fix the mapping export from Archicad. This needs to align to basic Revit defaults in the mapping default. Remember the mapping default template, or you can tweak the IFC import settings in Revit. Okay, you can tweak the settings in Revit. Secondly, define the IFC type in Archicad for slabs so that Revit can assign to the proper Revit category. And thirdly, before importing in Revit, please review the IFC file using IFC viewers like OpenIFC Viewer, BIM Vision, etc. to check if the IFC class are properly defined prior to importing in Revit. Okay, so we'll take questions later. Thank you very much, and I'll pass over the baton to Vimal from Graphisoft.
Okay, thank you. All right, good evening, everyone. So myself, Vimal from Graphisoft. So let me go through with you guys the IFC interoperability best practices with Archicad. Before that, let me just explain to you the Graphisoft ecosystem for IDD. So we have Archicad as our BIM authoring tool. which can perform the issue management, multidisciplinary coordination, and collision detection within ArchiCAD. So even if you are bringing in IFC files from the other tools, you can import it inside ArchiCAD, and you can just do coordination and collision detection within ArchiCAD itself. And we also have model comparison. So you can compare models between ArchiCAD files, or even if it is an IFC file, you can do it just within ArchiCAD. You need not have another tool to do these kind of coordination and collaboration workflows. And we can also generate the structural analytical model based on your BIM model with few rules that you can define inside ArchiCAD. And then you can export this structural analytical format in SAF file format, or even as an IFC structural format, and then you can import it inside the structural analytical tools. And then if there are any changes during the structural analysis, you can just bring back those changes inside ArchiCAD, and you can perform, like model comparison, and then you can accept or reject the changes. And we can also perform one integrated model inside ArchiCAD, where you can let people from different disciplines work together in a single ArchiCAD file, and then you can develop your project. And talking about BIMX, which is our data access tool, so we can have virtual reality using the Google Cardboards. And we also have hyperlinked 2D and 3D models, which you can open and then access your project information from anywhere using your mobile devices. So you have to export your ArchiCAD model to BIMX to access this information using your mobile devices. And it can also be accessed using your PCs and MacBooks. Okay, and we can also use BIMX models for ICE coordination, integrated concurrent engineering coordination with minimum resources, and you can do it online itself. You can send across messages to different people by selecting an element, doing a markup, and then they'll be able to receive even if they are working inside ArchiCAD. Say, for example, if you are at site and if you want to send information to people who are doing modeling within ArchiCAD, you can send across these messages. And we have BIM Cloud, which supports the teamwork functionality. So you can stay around anywhere in the world and then join the project inside BIM Cloud and then work together to deliver your project. And it has a built-in communication tool as well, using which you can communicate with your team members regarding your issues, or even if you want to, subscribe to an element and then understand if there are any changes happening on to those elements, you can use this built-in coordination or communication tool to perform those workflows. And Graphisoft believes in openBIM, and it fully integrates and supports openBIM workflows in all these products and ecosystem. Okay, and as I was telling, Graphisoft is supporting IFC 2x3 and IFC 4, and it is fully certified for both export and import. So let us go into the best practices for IFC export. I'm going to focus on IFC export in this presentation from ArchiCAD. And so here are the best practices. Let us go through one by one. The first one is classifying the elements. So classification is basically the key. So within ArchiCAD, ArchiCAD supports multiple classifications. You can use multiple classifications, but for IFC workflow, we recommend to use ArchiCAD classification version 2.0, which is basically the default classification. And when you do a classification, right, it has multiple reasons. One is basically to export. The foremost important for today's presentation is to export the IFC file based on this IFC, based on this ArchiCAD classification. Okay, the other important reason for classification is also to attach the element properties to different elements based on this classification. So ArchiCAD is quite flexible, so you can use any tool to create your elements. But end of the day, if you classify those elements correctly, you will import all the properties that are required for that particular classification, and then it will be able to export them with the IFC properties into the IFC file. Okay. So the best way, or the easiest way to do the classification, or the traditional way to do the classification, is just open the element settings, and then you can go to the classifications and properties, and then you can choose the classification of an element there, and then so that you will see all the properties attached to those classification inside the element settings, which you can key in the values, and then you will be able to export them with the IFC file. Okay, you can also use the schedules. You can just basically create some schedules, and then you can change the classification as and when required, or you can manage your classification using this schedules itself. Okay. And as I was talking about classification, this ArchiCAD classification version 2.0 is very similar to the IFC entity schema. So whatever classification you have inside Archicad, it will have a corresponding IFC entity to that in the IFC schema. Okay. So even if you are adding any new classification item inside the Archicad classification version 2.4, say for example, in Singapore, we have refuse chutes, which is not really available on the IFC entity schema. So you can add those to the classifications, and then probably we have to do a IFC type mapping, which later I'll be showing, so that it can achieve the mapping between the classification and then the new IFC entity that, or the IFC type that we are trying to create. Okay, so let me show how it works inside Archicad here. So you can select any element and then go to the settings of that element, and under the classifications and properties, you will be able to select the classification. And based on this classification, you can see this particular element will have the properties attached to that classification. And also it translates to the IFC as an IFC door with the predefined type or user defined type that has been defined for this classification. Okay. So once we do the classification, we need to check whether all our elements are classified or not before we export the IFC file, right? So you can use graphic overrides, and in this graphic overrides, we have created a rule in such a way that if the element is not classified, it will be red in color, and all those that are classified will be white. So this visually lets you understand whether the element is classified or not. And if it is not classified, you can just go ahead and fix it immediately. Okay, so you can see here this particular column is not classified, and once it is classified, you can see it becomes an IFC column. Similarly, we have this grill gate object. It is currently unclassified, and you can see it is a building element proxy. And once we change it to the right classification item, it will have the IFC entity type and also the user defined type of that particular element. Here you can see the predefined type is gate, and then the IFC type is IFC door. Okay, so this visually helps you to classify the element, and you can find this graphic overrides inside the IFCSG template as well. And as I was telling earlier, you can use schedules also to do the classification or manage the classification. So here in this case, right, you can see this particular door, which is actually a blast door, is classified, but it is not rightly classified. So here you can see I can choose the element and then change the classification. And if you want to see that back inside 3D view, just select the element and then go to the 3D view. And you can see once the classification is changed, you can see the object type, and the user defined type is blast door with the IFC door entity. Okay, so you can basically use this translators or the schedules, and then you can manage your classification of your elements or even for your subtype elements. Okay, and another important thing that I want to cover regarding the classification today is for the Archicad's hierarchical elements. So for example, for staircase, right, we have IFC stair. And inside the IFC stair, we will have IFC flights and IFC landings and so on. Okay, the IFC slabs for landings. Okay, so overall, IFC stair can be classified as a stair, but you can see if you go further inside these hierarchical elements inside Archicad, you will have classifications for each of these sub elements. So here I'm selecting the flight, and then I'm going to classify it as a stair flight, or it can be a straight or curved, depending on the project or design requirements. And also for the landing, you can here choose the landing slab, or you can choose stair landing here. Okay, so it will be exported as an IFC slab. Okay, similarly for the treads and risers, we have the classifications and properties as well. So you need to classify each of these subtypes in the right classification so that the element gets exported correctly to the IFC file format. So here you can see for the curtain wall, I'm showing another example of the frames. So here you can choose curtain wall frame for the frames, and then you can see go inside the IFC type, it becomes an IFC member, and then the predefined type becomes a Boolean. Okay, similarly for the panels, you can select and then you can choose the correct panel type under the classification so that it translates to the IFC plate with the curtain wall predefined type. Curtain panel as a predefined type. Okay, so this is very important, and you need to be careful. Even for stairs and even for railings, we do have the same kind of setting. So we have railings, we have bollards, and we have posts and so on. So all that need to be classified within the subtype so that it exports or translates correctly to the IFC subtypes inside the IFC file. Okay. So after doing the classification, the next step is we need to be careful with the mapping of these classifications to the appropriate IFC entity types. This is automatically or predefined within the IFC translators. But if in case you want to do any changes, you can do that as well. So just have to go to File, Interoperability, IFC translators. And then we just have to open the IFC translator that you want to edit and go to the type mapping. And from there, we can edit the translators, the mapping of this IFC types. Okay, so let us see that in action here. Open the translators and then go to the type mapping. And then go to this map IFC. So here you can see we have all the elements that are predefined as per the IFC schema, and it is mapped together with the IFC class Archicad classification. So here I'm showing the IFCSG setup where we have area strata as one of the classification item. So once you classify it correctly, you can see the user defined type will be attached to that. So this can be edited if in case you want. Say, for example, if you want to add a new classification item, you have to come here and then select the classification item and then choose the appropriate IFC type here. So here you can see I'm changing this accessible route to an IFC civil element, and then I'm keying in the user defined type as accessible route here, so that when you classify the accessible route using the classification, it will be exported with this settings to an IFC file. So this is a one-time effort, and all this has been done for the IFCSG standards and requirements inside our template. You can just simply use it. Okay. And another thing to be careful while you export, right? Say, for example, when you export a curtain wall, whether you want to convert that to a single element or to keep the hierarchy of the element. Similarly for the stairs and railing as well. So if you convert to a single element, it will just be a curtain wall, IFC curtain wall, and you will not be able to see the IFC plate or IFC member inside each of this element type. Say, for example, stair, you will not see the IFC stair flight, so that you will just only see the IFC stair. So you need to classify them, and then you need to make sure whether you want to keep the hierarchy or you want to convert them to a single element. Okay. So the next step is model verification. So to perform model verification, we can do it within Archicad itself. So we can use IFC Project Manager. So this is a dialog box where you can open your IFC. Basically, you are opening your project in an IFC schema format, and then you can check whether the elements are having the right classification or right IFC type, whether it is translating before you export. So meaning you need not every time export your IFC file and then open it, wait for it to export so long, and then open it inside an IFC viewer to check your classification, to check your translation, to check your properties and everything. So you can do it within Archicad itself using this IFC Project Manager palette, and then you can just check before you export these IFC files. So basically, you can see here, if you find any building element proxy element, right? So you can see there is this IFC building element proxy. It means that it is either not correctly classified, the elements are not correctly classified, because if you leave any element unclassified, it will be translated to an IFC building element proxy. And if it is an IFC building element proxy, you will not have the necessary information attached to that particular element inside the IFC file. So you need to be careful while you are exporting the IFC file. So just open your IFC project manager and then make sure you don't find any building element proxy. And even if you have building element proxy element, right, it could be an intentional classification. So there is a classification for building element proxy, but it is intentionally classified as building element proxy. It is not like leaving an element unclassified so that it automatically converts to an IFC building element proxy. Okay. So let us see how this works inside Archicad. Go to the IFC project manager, and then you can select each and every element, and then you can find out whether it is translating to the right IFC element type and then the predefined type as well. Okay. So you can select any particular element and you can do that. So if you have this particular slab, you can see there is an opening element also inside that, and it also gets attached to that IFC slab, and you can check whether it is rightly translating. Okay. And one another use for this IFC project manager is also to check the properties attached to this elements, whether it is rightly translated, or even if you want to change any of the property values, you can just select the element and then change the property value or add new properties to those elements is possible within this IFC project manager. Okay. And of course, once after you do the model verification inside Archicad, you can once export, like before you pass the IFC file to the project stakeholders, you can just export and you can even check it with IFC viewers like BIM Vision or Solibri Anywhere and so on. Okay. And then when we are talking about IFC translation to different parties, right? Like for receiving end for today's presentation, we are concerned about Revit, and as Saga was mentioning earlier, so we need to be careful with the IFC import options with Revit. So even if sometimes you classify it as an IFC covering, and if you're not subclassifying it as a ceiling, it will not be translated to an IFC to a ceiling element inside Revit. So you need to work with your project stakeholders on the receiving end on which tool they are using. In this case, we are showing Revit, but it can be any other tool. So you need to understand how the translation works between the receiving end and then the one who is generating the IFC file. And then you have to understand the translation and then tweak the translation according to the file that we are creating or how it receives inside the downstream side, so that the tweaking is done and then the file could be used for, say, for example, if you want to use the file for further editing, right, which is normally not recommended by buildingSMART. But if you are trying to use the IFC file for further editing inside Revit, we recommend to use IFC 2x3 for this particular workflow. So this is what we are recommending as a workflow for translating information from Archicad to, say, for example, Revit. Okay. So if you have any questions, feel free to write to me, and then I will pass back to Vanessa for the Q&A session.